Welcome, everyone, to the Tao Salon of Statistics. If you've ever felt like you're just being tossed around by the random currents of business and life, well, you've come to the right place. Today, we're going to learn how to actually read those currents to find a little clarity in all that chaos.
That's the big question, isn't it? We all face it. Whether you're trying to figure out if customers are going to like that new feature, or you're running a factory where just one little hiccup can shut everything down. How on earth do we make smart moves when we can't be sure what's going to happen next?
Well, here's the secret. You don't fight the river of uncertainty. You don't try to build a dam against it. No, you learn to read its flow. And that, right there, is what statistics is all about. It's the Tao, it's the way to not just survive randomness, but to actually work with it.
So, to start this journey, we first need a language. We need a way to talk about all this random stuff that's happening in a way that's clear, that's measurable, and it's actually useful.
Okay, I know this sounds a little academic, but stick with me, because it's a really simple and powerful idea. A random variable is just our tool for turning a fuzzy, uncertain outcome into a hard number we can actually work with. So instead of saying some customers might click our ad, we can say, let X be the number of customers who click. And just like that, we've got something we can measure, analyze, and even predict.
Now, this new language we're learning, it kind of has two main dialects. And it all boils down to a simple question. Are the outcomes things you can count, like 1, 2, 3? Or are they things you have to measure on some kind of scale?
This slide just lays it out perfectly. Think of our river metaphor. Discrete variables are like counting the individual waves that pass by. 1 wave, 2 waves, 3 waves. It's distinct. Continuous variables, on the other hand, are like measuring the depth of that river. It could be 10 feet, it could be 10.1 feet, or even 10.1123 feet. The possibilities within a certain range are pretty much infinite.
So when we're talking about stuff like the number of sales you made this week or how many customers are waiting in line, those are all discrete, right? You can't have 2.5 sales or 3.1 customers. The outcomes are whole countable numbers.
But then you've got things like time, weight, or volume. And now we're in the world of continuous variables. A can of soda isn't just full or not full. It might have 12.01 ounces, or maybe 11.98. The possibilities are endless. And getting this distinction right is absolutely crucial, because it decides which predictive tools we can even use.
Okay, so we've got the language down. We can describe the currents of chance, but how do we start predicting where they're going to go? For that, we need maps. We need models that show us the landscape of what's probable.
This right here, this is our map. A probability distribution shows us the likelihood of every single possible outcome. Now, it won't tell you what will happen, but it gives you fantastic odds on what's likely to happen. And in the business world, there are 2 of these maps that are just legendary.
First up is the binomial distribution. This is your absolute best friend for any situation that boils down to a simple yes or no, a success or a failure. Will a customer buy the product? Is this part from the factory defective? As long as each event is independent and has the same chance of success, the binomial model is the perfect tool for the job.
And then we have the heavyweight champion of the world, the normal distribution. You know it as the iconic bell curve. And what's so amazing about this thing is that you see this shape everywhere in nature and in business, from people's heights to tiny variations in a manufacturing line to the daily swings of the stock market. It's like the fundamental fingerprint of random processes.
And here's the great part. Using this powerful map is easier than it looks. It's really just 3 steps. First, you sketch the curve to get a picture of your problem. Second, you convert your number into something called a z-score. Think of a z-score as a universal yardstick. It tells you exactly how far your data point is from the average. And once you have that z-score, you just look up the probability in a simple table. That's it. It's a simple process that unlocks some incredibly powerful insights.
So we've got the language, we've got the maps. Let's make this real. How do we actually use these tools to make better, smarter business decisions? Let's break down 3 huge ideas.
First up is expected value. This is the secret weapon of casinos, insurance companies, and every sharp investor out there. It's a way to figure out the average result of a risky decision if you could make it over and over and over again. You just weigh each possible outcome by how likely it is to happen.
Just look at this insurance policy. The company makes a small profit on almost every single customer, but once in a blue moon, they take a huge loss. So how do they stay in business? By using expected value, they can calculate that, on average, every single policy they sell is worth $280 in profit. That's the magic of it, turning a whole bunch of unpredictable events into one reliable, long-term number.
And this concept is everywhere. It's the rock-solid foundation of modern finance and risk management. It lets companies put a real number on risk, price their products for long-term profit, and compare totally different investments on an even playing field.
All right, our second big idea is all about becoming a master of those yes or no situations. And that's where our friend the binomial model shines. It is the perfect tool for any process with just two possible outcomes.
Look at this manufacturing line. Let's say there's a 10% chance any given part is defective. Well, with the binomial model, we can calculate the exact probability of finding, say, exactly 3 defective parts in a small batch of 5. It takes a general rate and gives us a super precise prediction, in this case, less than a 1% chance. It's incredibly specific.
And this model is an absolute workhorse in business. Quality control teams use it to predict defect rates. Marketing uses it to forecast how many people will click on an ad. And if you've ever run an A/B test on a website, the binomial model is what tells you with statistical proof that yes, version B is definitely better.
And that brings us to our final big idea, the master tool itself, the normal distribution. This is how businesses really get a handle on managing and optimizing any process that tends to cluster around an average value.
Imagine you're managing a paint factory, and daily production follows that classic bell curve. You decide you want to give a bonus to your crew on their top 10% best days. Well, instead of just guessing, you can use the normal distribution to find the exact production number, 112,800 gallons, that marks that cutoff. All the guesswork is gone. It's a precise, data-driven target.
The power here is just immense. Businesses use this to manage inventory so they don't run out of stuff, to optimize entire supply chains, and to model the most likely range of returns on an investment. Honestly, understanding the bell curve is like having the secret blueprint for so many critical parts of a business. So, as we leave the salon today, let's just quickly recap those 3 huge ideas. First, we have expected value, which lets us turn risk into predictable, long-term profit. Second, there's the binomial model, our go-to tool for any yes or no question, from quality control to marketing campaigns. And third, the incredibly powerful normal distribution, our blueprint for understanding and optimizing countless processes. The takeaway is this: randomness isn't just noise. It has a pattern. It has a language. The world is a river of uncertainty, for sure. But with these tools, we're not just drifting anymore. We are the navigators.